The greatest killer on Earth isn't an asteroid from space or a supervolcano churning beneath our feet. The most efficient and ruthless architect of planetary death has always been something far closer to home. It's the one thing that covers over 70% of our world's surface. And it's starting to show the same warning signs it did, right before it wiped out nearly everything. The question isn't if the next mass extinction will happen. The question is, has it already begun in the silent, dark depths of our oceans? To understand the threat, we have to travel back in time, not just a few thousand years, but 252 million years, to the end of the Permian period. The world then was a single, giant continent called Pangaea, surrounded by a single, massive ocean. Life was thriving. But then, something went catastrophically wrong. In what seems like a geological instant, 96% of all marine species and 70% of terrestrial life vanished. It was the closest life on this planet has ever come to being completely erased. For decades, scientists blamed volcanoes in modern-day Siberia that erupted for nearly 1 million years straight, spewing greenhouse gases into the atmosphere. The planet warmed, and that was that. But the real kill mechanism wasn't the heat itself. It was far more sinister. The smoking gun wasn't found in the air, but in the water. The oceans had turned into a toxic, suffocating soup, and the evidence is buried in ancient seafloor rock all over the world. Imagine holding your breath, first for 30 seconds, then a minute. Now imagine an entire ocean holding its breath for 1,000 years. This is what scientists call an oceanic anoxic event, or an OAE, and it's the first step towards global annihilation. Here's how it works. As the planet warms from massive amounts of CO2, the oceans warm too. A fundamental law of chemistry is that warmer water holds less dissolved oxygen. At the same time, the warmer climate leads to more rain, which washes huge amounts of nutrients from the land into the sea. This triggers gargantuan blooms of algae, bigger than entire continents. When this massive blanket of algae dies, it sinks to the ocean floor, and as it decomposes, bacteria consume all the remaining oxygen in the deep water. The ocean literally begins to suffocate from the bottom up. A layer of zero-oxygen water, black and lifeless, begins to grow. During the Permian extinction, this anoxic layer swelled from the abyss until it poisoned even the shallow coastal waters. For 96% of marine life, there was simply nowhere left to breathe. But suffocation was only part of the horror. What happens in an ocean with no oxygen is the stuff of nightmares. When there's no oxygen for bacteria to breathe, a different kind of microbe takes over. These are sulfate-reducing bacteria. They don't need oxygen. Instead, they thrive on sulfates, which are abundant in seawater. And as they consume it, they release a waste product. That waste product is hydrogen sulfide, a highly toxic, flammable gas. To us, it smells like rotten eggs. But in high concentrations, it's a lethal poison. It attacks the nervous system and shuts down cellular respiration. In a dying ocean, these bacteria can multiply on an unimaginable scale, producing colossal amounts of hydrogen sulfide gas. At first, it just saturates the deep ocean, killing anything that wasn't already suffocating. But then, the anoxic ocean burps. Huge bubbles of this toxic gas, now dissolved in the water for centuries, erupt into the atmosphere. The effect would be instantaneous and apocalyptic. The sky would turn a sickly green, and the air itself would become a weapon, killing animals and plants on land that had been completely untouched by the chaos in the sea. This isn't speculation. Geologists have found chemical traces of this poison gas in rock layers from the Permian extinction, perfectly matching the timeline of the die-off on land. The ocean didn't just suffocate its own inhabitants, it actively gassed the rest of the planet. It's even stranger than that. While most life was dying, some things thrived. In this toxic, oxygen-free water, bizarre ecosystems of chemosynthetic organisms took over. Green and purple sulfur bacteria, which live on toxic chemicals, would have turned the surfaces of the oceans into vast, putrid, violet-colored mats. A literal alien planet, right here on Earth. So a warming planet, massive nutrient runoff, and expanding dead zones. Does any of that sound familiar? Today, our oceans have absorbed over 90% of the extra heat trapped by man-made greenhouse gases. The result? Ocean temperatures are breaking records every single year. At the same time, fertilizer runoff from industrial agriculture is pouring into the sea, creating the largest algae blooms in dead zones ever recorded. There are now over 400 of these documented dead zones around the world, some spanning over 70,000 square kilometers, an area larger than the entire country of Switzerland where nothing can live. Scientists are now observing that these oxygen minimum zones are expanding on a global scale. We are, quite literally, creating the exact same preliminary conditions that led to the Great Dying. We aren't at the hydrogen sulfide stage yet, but we're running the same experiment. We're turning up the heat, dumping in the nutrients and holding our breath, hoping the result this time will be different. The rock record shows us, with terrifying clarity, what happens next. The oceans, the cradle of life, can just as easily become its tomb. And the warning signs aren't just in the ancient past. They are flashing red in our world, right now. The question is no longer what could happen, but whether we're willing to listen to the echoes of a 252 million-year-old catastrophe before it's too late.